Hello guys, welcome to the networking workshop. In today's workshop, you guys will learn the basics of networking, how exactly what networking is, how the communication happening from one place to another place. I'll try to cover a little in detailed. Okay, so I need all of your response. So please interact in the session to make um, the session more enjoyable. Okay, are you guys ready?
Yes, sir.
Well, yeah, thank you, Shubham.
Sir, whatever you are teaching to us, can you, after the class, can you send it to in this group? Recording or
Yeah,
PPT?
yeah,
Anything else?
I can give you a recording.
Okay, okay, sir. ठीक है.
Yeah, okay. So normally, like networking is nothing but it is just a communication between two different computer or to computer or to any network devices. Okay. So if any communication, if any data flows from one place to another place, we call that as a network. So here you can see I have two computer connected together. Um, the computer A sends the data to computer B, then computer B will give some response. Okay, so this is not a very simple communication. Here we need more things. First one, we need a sender, the person who sends the data. We need a receiver. We need a transmission medium. We need a message. We need a protocol. Okay, we need 5 component to make the network process. Okay, so sender is done, receiver is done, transmission medium, how I'm connecting, whether wired or wireless. I need a protocol. So here in the computer communication, protocol is termed as the IP. Let's say 10.0.0.1, 10.0.0.2. You don't need to worry about it, what these numbers are. You can just assume it is just a name for PC, computer. Okay, it's just a name. So this name have 4 blocks. Each block will have a number from 0 to 255. That's it. Okay, let's try to do one lab with this. I'll take 2 computer, I'll connect and I'll show you how the communication. So to do the lab, I can use a Cisco packet tracer, which is officially given by Cisco to perform all the labs. Okay, because I cannot show with the hardware as of now. So we can use this emulator to perform all our labs. You can see I'm just clicking the end device. If I click the end device in the bottom left, I can see PC, laptop, everything. Let me take a PC. It is just drag and drop. You can drag and drop here. Okay, let me maximize it so that it will be more visible. Okay, so you can see I have 2 computers now. Now I need to connect these two. Let me take this cable. The fourth one, the component, sorry, the connection. If I click the connection, I can see the thunder symbol. You can just click the PC and the another PC. Now the connection is established. You can see it is green color. So if it's a green color, it is connected properly without any issue. So sender is done, receiver is done, the transmission medium also done. Now we need to configure a protocol. So I already written some IP address here. We can use the same as of now. So okay, if I just click the PC, I'll get this prompt. Here there is something called desktop. I'm just clicking the desktop. Then we have something called IP configuration. I'm clicking that and I'm typing 10.0.0.1 Just enter it. Something like subnet mask will get filled. You don't need to worry about it. You can leave it. The another one, again, desktop IP configuration type 10.0.0.2. You cannot change the IP address structure. You need to follow this rule. It should have 4 blocks. Each block number should be from 0 to 255. I'll explain detailed in the upcoming sessions. Okay. So as of now, we just configured IP address for 2 PC. Now we need to initiate the communication. Okay. For making the communication, we can use a command prompt. So I'm in the first PC. I'm just closing this. There is something called command prompt. It is like your Windows command prompt. I'm clicking it. You will get this one. You can able to type, and you will type as a text. You will get a response as a text. I'm typing ping, then IP address of the destination. So my IP address is 10.0.0.1, and I'm trying to reach 10.0.0.2. 10.0.0.2. You can see we are getting a response from the destination. So you can see we are getting a response from this particular IP. That is what we are trying to communicate. And I'm sending 32 byte of data, and I'm getting a response in 1 milliseconds. Okay. So this is how the communication happened between 2 PC. Clear? Any doubts? Abhijit, Shubham, and others.
Yes, sir.
Okay. Now let's go deeper. We'll learn how exactly the communication is happening, what happened in the background. I am turning on something called simulation here. If I just turn on the simulation, I can see the data flow here. Okay. So I'm just pinging. Okay. I just initiated, but my source PC didn't send the request. So I need to forward the request to the destination. Destination will analyze the request and will give a response. Okay. So this is how the flow. Like if I check now, you can see I got one reply. So this is how we get a reply whenever we send the request. And now the second request is ready. I'm just clicking it. I'll show you what happened inside it. So you can see, you can leave the Ethernet header as of now. In the IP header, you can see my IP address 10.0.0.1, and I'm trying to reach 10.0.0.2. So these are the source and destination IP. So when I'm sending the request to the receiver, they will check the data, who sends the data, to whom we need to reply. So those information they need to know, and they will check what data they sent, ICMP. So now I'm sending, so receiver checked it, they need to reply. So when they receive it, source IP will be 10.0.0.1, which is source. When they send, source IP will be their IP 10.0.0.2. The destination will be 10.0.0.1 because they need to reply. Okay, so this will be forwarded. Once the PC3 receives it, you can see second reply. Okay, like this, the third request, third reply, fourth request, fourth reply. Okay, it is done. So this is how the communication happen between 2 PC with the source and destination IP. Okay, clear?
Yes, sir.
Yeah. So whenever the communication happen, everywhere the same thing. So let me take little more real time. So let me open command prompt in my computer. Okay, so I'll just ping dot com google.com hyphen 4 I'm using for the IPv4 address. Enter. Okay, like how it was happened in the packet is the same thing is happening here.
Sir, why you written your IPv4 hyphen 4?
Uh, by default, it will take IPv6. If I'm not mentioning it, it will take IPv6. That's it.
अच्छा अच्छा.
Okay. Now what I'm going to do, I'm going to show you the data flow in my computer. For that, I need a tool called Wireshark.
Yes, sir.
So I already have that application in my system. I will share the link to download that particular application in the group. Okay. So I'm using the Wi-Fi, so I need to capture the Wi-Fi traffic. Okay. You can see
That what exactly Wireshark do?
now I have connected to internet, right? Some data will send from my computer to internet. From internet, some data will come back, right? Everything you can see from here. So I'm trying to ping google.com here. Okay. I need to capture what I'm sending. Let me mention IPv4. Enter. You can see I'm sending 4 requests. I got 4 reply. If you see it here, let me erase it first. Okay. So my IP address is 192.168.0.104. So from my computer, I have sent a request, basically ICMP request to this particular destination. This is what google.com. From google.com, I'm getting a reply to my system. So let me maximize it. So this is ICMP echo request. In bracket, it mentioned ping, which we are using the tool. ICMP echo reply. Again, second reply, third request, third reply, fourth request, fourth reply. So we send 4 requests one by one. We received 4 reply one by one. And if I just click, I can able to see the headers here.
Sir, in the previous UDP protocol is used, but here ICMP protocol is used.
In previous also ICMP only in the packet tracer.
अच्छा अच्छा.
Okay, so you
Okay,
can
sir.
see if you just drop down the IPv4 header, you can see the source IP, destination IP, and there is a separate ICMP header which contain information about the echo request. If you click the reply, you can see the information about the echo reply. Okay, so this is how we do. This is how much deeper we go. Okay, so if you guys have any questions, doubts, you can ask me now, or else I'll move forward.
No, sir, please move forward.
Yeah, sure. So, like whatever data sent by this PC through this cable will be in a form of electrical signals. Okay, so these electrical signals, basically it is a sine wave. Um, you can, I hope you know about the sine wave like this. Okay, so this is one, this is zero, one, zero. So your data will be in a form of zeros and ones through the cable or through Wi-Fi, wireless, in both the form. Okay, so we have some standard uh, for the networking. Okay, so that is what OSI. So Open System Interconnection. So like let me give some more theory why we need this OSI model. Okay, so like here I just say the data in a form of zeros and ones. Okay, so here I can just say the data in a form of zeros and ones. In many places, we can easily predict, oh, this is a place, so the data form will be this, like uh, bits, frame, packet, segment, and data. So these many data format, we call it as a PDU, protocol data unit. Okay, so this OSI model will give you clear understanding how the networking is. Okay, so let's begin to the OSI model. So before starting the OSI model, we'll understand why we need a OSI model. So in 1970s or 1980s and all, the company they use Dell computer, IBM, um, some different vendors. Okay, if a company use 100 Dell computer, uh, some 5 to 6 computers got repaired. Okay, so out of 5 to 6, we cannot replace those 5 to 6 computer with um, HP or Lenovo or IBM. The entire company using a Dell, we need to only replace with the Dell. The reason is uh, Dell to IBM communication won't happen. The different vendor communication won't happen. Okay, the reason is each vendor they have their own standard for designing, developing, implementing their network devices, network component. Okay, so it is not like the single standard can be followed globally. Okay, so what happened after that? There is a person called ISO, International Standardized Organization. They created something called OSI, Open System Interconnection. It is a set of rules and regulations to be followed for designing, developing, and implementing related to the networking. Okay, so these ISO strictly told if anybody want to sell their product, they need to follow OSI model, or else I won't standardize your product. So this is a strict notice to all the vendor company. Vendor means the manufacturer like Dell, HP, IBM, Lenovo, etc. So they started using this OSI model for designing, developing, implementing their network components. Okay, that is the reason uh, how and why the OSI model comes into the picture. Is it clear? Why this much dead silence? Hey, Abhijit, Aditya, Shubham. I think my story made you guys sleepy. Is it? Okay, fine. So, so the reason why was it connecting to different vendor, ASAP troubleshooting, easy to troubleshoot, and PDU, and all the 7 layers. What is the data format for each layer? Just read it. I'll give you 1 minute time. Okay, I hope it's clear. So let's talk about each layer one by one. Physical layer first. So we have physical layer, data link layer, network layer, transport layer, session, presentation, application. In the physical layer, it is not like all the physical devices. It is only the component which helps to connect. Okay, cable, Ethernet cable, fiber cable, wireless, Wi-Fi signals. So everything comes under the physical layer. So whatever devices in the physical layer, those data units, bits, data will be in a form of zeros and ones. Okay, 1 byte equal to 8 bit, 1 kilobyte equal to 1024 byte. You can see this. Okay, for more understanding, you can pause the video and you can check it. Okay, so cable hub RJ45 fiber cable. So this is what the Ethernet cable is. So this is for what RJ45 connector. Registered jack 45 is the size connector. Okay, and you can see how the 0 and 1 communication between to PC through the cable. Okay, it has so many algorithms, but we don't need to go in depth in that layer one. And second one is a data link layer. So basically, data link layer is in the layer two one. So data link layer is a layer two one, which use MAC address for the communication. Okay, so even between two PC communication, PC1 to PC2 communication, here the zeros and one communication, but once the PCB receives all the zeros and ones, it will convert the bits into frame. Okay, this will happen. Okay, so the PDO is frame, and in this layer we have a device called switch. Like previously in the layer one or the physical layer, I told like the cables and all. So here we have a device called switch. Basically the layer two switch. This use MAC address for the communication, and uh, like when it convert from the bit to frame, the MAC header will be attached in this layer. Okay, and we call the MAC address as a physical address, hardware address, permanent address. Okay, so these are the different name for the data link layer. And this is how the Ethernet frame look like. You can see the preamble 7 byte. So this is kind of some unwanted or junk zeros and one, which helps to protect the total frames. And SFD, start frame delimiter, which helps to indicate whether the frame is started or not. And this is destination address. Why here 6 byte is IP, sorry, MAC header contains the MAC address, right? The MAC address size will be 48 bit. 48-bit hexadecimal. To store that, we need the same 48-bit or 6 byte. Both are same. Again, for source MAC address, we need 6 byte. So this is type. It will indicate what type of data it going to carry. So it have 2 byte, and the actual data will be stored here. So if you're just pinging, the ICMP will be inside this. Okay, for your understanding. So it can hold the data from 46 to 1500 byte. Also, the last one is the FCS frame check sequence. So it is an error recovery protocol. It use CRC. Okay, CRC stands for cyclic redundancy check. So in the like CCNA course, you will be learning everything in detail. As it's a workshop, I just quick through it. And network layer. So network layer is a layer which helps to connect two different network. A router will be used in this layer. If you have two network, LAN 1, LAN 2, so you need a WAN. In WAN, we have a router. So to connect to two different LAN, we need a WAN. Router will be used in the WAN. So this is what network layer. Not only this, even between two PC, we are using IP, right, for the communication. Here also network layer will be used. Wherever you are seeing the IP address based communication, the network layer will be the main part. So bit will be converted to frame, frame will convert to packet. Okay, so IP header will be encapsulated to the data in this layer. So routers are network layer devices. It have two functions. One is the logical addressing. We are assigning the IP address manually or through some protocol. It helps to assign IP address to the device. Logical addressing. Routing, it helps to provide the reachability to the destination. For example, I pinged from my system to google.com. It given the reachability, right? That is what the routing. And path determination. To reach a google.com, it needs to go with some path. That is what the path determination. That also done by the network layer. And the example device is router. And the PDU unit is packet. Any doubts in this? I guess so far no doubts. Okay.